So we're going to continue our study today with surface area. One big difference is that I'm not going to have you do any practice problems. I just want you to watch the video and be exposed to how to do this. So in the past couple days, we've been talking about rectangular prisms, rectangles on the end with rectangles in between, keeping those spaced apart. You know that you can also have a triangular prism, so it has triangles on the end and rectangles in the middle, keeping them apart. So there's a triangle, and there's a congruent triangle. They are exactly the same. And then there are three rectangles in the middle that keep them spaced apart. When you went to find the surface area for a rectangular prism, you could do each of the 6 sides individually and add them up. We remember that we did the colors, so you could do 2 and 2 and 2. You could do one of each, add them up, and then double it because you know you're going to get double. Or there was that wonderful formula, surface area equals 2LW, 2LH, 2WH, and you add all 3 up. Unfortunately, there is no formula for a triangular prism. You have to do each of the sides individually. Every now and then you'll luck out, and the triangle on the end will be an isosceles triangle, which means 2 of the sides will be equal, in which case 2 of the rectangles will be equal. Every now and then, even less of a chance, you'll get an equilateral triangle on the end, which means all 3 are the same and all 3 rectangles are the same. Little less calculation. But most of the time, you're going to get a scalene triangle where all 3 sides of the triangle are different lengths, which means all 3 rectangles are also different lengths. So this lovely prism looks like this when it's opened up. We have the 2 triangles on the end. I kept them both white because they will be congruent. They will be the exact same. And in this case, each of the sides of the triangle is a different measure. This one here would be 3. If I was to put these up together, it matches with the blue over here. So this would be 4. And if I was to put this up together, it matches with the green over here. So this one would be 5. So this is an isosceles triangle. These are the same triangle. So if you find one, you can just double it. And each of these rectangles will have to be calculated individually. Okay, so since we know these measures, we can calculate this. I'm going to run through just one of these with you. Get my folded ones out of here. Now, when you do something like this, you need to stay very, very organized. So I might say something like the triangles, the blue rectangle, the pink rectangle, or red, I don't know what that is, and then the green rectangle. Keeping things very organized. If you didn't have colors already in, you could say like top, middle, bottom, A, B, C, whatever you want to do. All right, so let's look at our triangle. I know area of a triangle is 1/2 times base times height. And there's going to be 2 of them. You can go through and do the 1/2 times base times height and then multiply by 2. But what do you know about 2 times 1/2? It equals 1. And if you remember back to when we did area of a triangle and I had that rectangle and I cut it on the diagonal and we had those 2 pieces, that's exactly what this is here. If I was to cut these off and rearrange them and put them together, these 2 triangles together would make a rectangle. So I can actually just use base times height. Now, there's lots of numbers on this picture. So let's think about the triangle. My base is going to be 3, and my height is going to be 4 because I'm looking for the ones that are perpendicular. When I go to stand this up, it's like a wall meeting the floor. There's my right angle, okay? So the base is 3 times 4. I have 12 square units for my ends. Now, I'm not going to do the half and the times 2 because remember, I already took care of that. If you wanted, you could do 3 times 4, cut it in half and get 6, and then multiply it by 2 again to get the 12. Same answer either way. All right, let's look at the blue section up here. It looks like our length times width, since it's a rectangle, is going to be 4 times 10. The pink rectangle, again, length times width, 3 times. Now this one doesn't have a second number, but I know if this is 10, my first dotted line here would be 10. So this rectangle is a 3 by 10. And then for the green, again, length times width, 5 times, well, if this is 10 and this is 10, then this must be 10. So that will be worth 50. Each of the pieces we found the area. Now when I go to put them together, I'm just going to add 12 plus 30 plus 40 plus 50. Sorry, I did a little out of order thing there. Community property lets me do that. So I'm going to do all my zeros first. This would be 90. 90 and 30 is 120. 130 equals 132 units squared because I'm not filling it. Just like when we did this and we did all the little squares and we counted them up, that's what's going on here. I would have a bunch of little tiny squares, count them all up, and it would take 132 of them to wrap the outside of this like a birthday present. Okay, if I had to put wrapping paper on it, it would take 132 square units. Right? Now, there is a phrase that I want you to type in. If you've made it this far through, I want you to email me. You have my email address. The phrase is "Go Lions." That will tell me that you watched the video. Now, there is another thing that you have to do today. It is a quizzes assignment on common denominators. Okay, so look for that second link in the weekly to do. If you have any questions, you know how to get a hold of me, and I will talk to you tomorrow.